Hi there, Algebra 1. 3.5, working with sets. Okay. Objective to write sets and identify subsets. To find the complement of a set. Okay, roster form. List the elements of a set within bracket. Or braces, brackets, same thing. A set builder notation. A notation used to describe the element of a set. So, a lot of times with this type of problem, you are going to, or with a builder notation, you are going to have your bracket. You're going to have X with a line, which I think it tells you X is an element of X. And then it's going to describe it. Maybe, I think like on the first question, it's going to be X is a integer, or it might be natural number. I think it's natural number. Okay, so that's part of my description. And X is, semicolon, X is less than 6. Okay? And then my bracket again. So, it basically tells you everything the sentence tells you. Not completely in just words, but in general. Okay, empty set is a null set. It is a set that contains no elements. Universal set is called the largest set. Complement of a set is a set of all the elements in the universal set that are not in that set. Is a set of all elements in the universal set that are not in the set. Okay. So, it would be a set kind of inside of a set. Okay. First one, how do you write T is a set of natural numbers that are less than 6? In roster form. Okay, roster form has to be in the brackets. Alright, so you have to be less than 6. We'll leave this one off just in case I won't bring it. It has to be less than, and it has to be a natural number. Natural numbers are 1, 2, 3, 4, 5, 6. So it has to be less than 6. So 1 is a natural number and it is less than 6. 2 is a natural number and it is less than 6. 3 is, 4 is, 5 is, and that is it. 6 is equal to it. We do not have the equal part. This is, so T equals this is roster form. Set builder notation is going back to this. So, T equals is a set of natural numbers. Okay, so natural numbers, X is less than 6. That is actually the straight up equation. I didn't remember it. Okay. Alright, N is a set of even numbers that are less than or equal to 12. Okay? Maybe we have to refer back to these, maybe we do not. Okay, first off, write it in roster form. N equals bracket. Okay? So you need even natural numbers that are less than or equal to 12. Well, 2 is less than, 4 is less than, and it is even. 6 is less than, and it is an even natural number. 8 is less than 12 or equal to, and is a natural even number. 10 is still smaller than, and is a natural even number. 12 is equal to, but we can be equal to in this one. So that one works because it is still an even natural number. So that is my roster form right there. Okay? Now if you remember set builder notation, N equals parenthesis, you can have x, your line down it saying it's an element, x is a even, an even rational, or natural, that should, not rational, natural, natural number, okay, and it has to be x is less than or equal to 12. There is that one. Okay. Inequalities and set builder notation. In set builder notation, how do you write this equation? So, the thing that you have to do here is solve first. So, I'm going to solve negative 5x plus 7 is greater than or equal to 17. Okay? I'm going to subtract 7, I get negative 5x is less than or equal to 10. Okay, I gotta get rid of this negative 5, so I'm going to divide by negative 5, divide by negative 5. When I divide by a negative number, I have to flip the sign. These cancel out, just leaving me an x. This is going to give me negative 2. So x is greater than or equal to negative 2. Now we need to put this in roster form. So I'm going to put my bracket. X is an element of x greater than or equal to negative 2. Close bracket. I don't have anything that tells me it has to be natural or even or anything like that, so I just have to put what I have on the board there. Okay? Now doing the last one. You have 9 minus 4n is less than or equal, or is greater than 21. So, subtract 9 from both sides. Gone. Negative 4n is greater than, subtract that, you're going to get 12, divide by negative 4, divide by negative 4, and, okay, we divided by a negative, so we got to flip the sign. N is going to equal negative 3. So we have now the element, or n is an element of n is less than negative 3. Pretty sure that's the element sign. I would have to double check that. That may be something I research on. Okay. Been a while since I've seen that one. What are all the subsets of 3, 4, and 5? The way I ended up explaining this to your classmates in class is, let's say 3 is a Snickers, 4 is a Reese's, and 5 is a Kit Kat. You have the option, if I have a bag full, I'm grabbing each one. So your subsets, if I only let you take one, is you're going to have a chance to get number 3, or the Snickers bar. You're going to have a chance of number 4, which is going to be the Reese's. And then you're going to have number 5, which was the Kit Kat. Okay? That is if I only let you choose one. Now if I let you choose 2, you are going to have the chance of getting 3, 4. So a Reese or a Snickers Reese's combination. 3, 5, which would be a Snickers Kit Kat. And you'd have 4, 5, which is a Reese's Kit Kat combo. Okay. Now, you also have the option to get all 3. So that would be my subset for this. Okay? Alright, what are the subsets of P and A? Okay, so if you have this subset, you can have A, right? For the first question, you could just have B. You could have A and B in the subset, and that would be your three options. Okay, what about A, B, C? Well, I could have just A. I could just have B. I could have C. I could have A, B. I could have A, C. I could have A, or you don't want E again. I want B and C together. And I have A, B, C. There is that one. Okay, if you go to 196, you have the ability to find the complement or complements of these sets. Universal, you have this set of chess pieces. It's on that page. You have a queen, a king, queen, bishop, knight, rook, and pawn. Okay? It says that is going to be your universal set, and then you have set A, which is a set of chess pieces that can move side to side. So they typically do it in a box. Now, you can think of this as like your counting numbers, your rational numbers, irrational, and the fact that, for example, counting numbers can be whole numbers because they're still part of it, but there's more specific part. So this universal, these are all chess pieces, but there's certain ones that can go side to side. If I recall, I have not played a lot, but a king will go side to side. So this is going to be my A set, this is going to be my universal. I believe a queen can go both, and I'm not sure, I'd have to look. I think it was knight. Your book will show you. So knight. All the other ones cannot. So your bishop couldn't, your rook couldn't, and your pawn could not. So all these are chess pieces, but this just classifies it a little bit less. This next one is a pretty good chance that I know this one a little bit better. Okay, so once again, your universal sets are going to be your whole group, which is going to be your months of the year. Okay? Now, they want to know your set A, which is going to be this little box inside it, is going to be your months with 31 days. Well, January has it. February does not. Okay? Okay, I think March does. April, I believe, does not. May, I believe, does. June does not. July does. August does. I want to say September, sure. This is when I gotta get a calendar out. I gotta make sure. Okay. January does, February does not, March does, April does not, May does, June does not. So we're good so far. July does, August does, September does not, October obviously does. October, November, December. That is how that one should be split up. There is your homework.